Welcome, friends. Let us have the fourth session on module 5 of network theory. Previously, we have discussed different theorems and we have solved many problems on them. Now, in this part of this module 4, we shall discuss primarily the problems from nodal analysis and mesh analysis. So let us proceed to our topic. Now consider figure 9. It is a figure with three meshes as indicated here. It is mesh number 1 is this, mesh number 2 is this, and mesh number 3. So the mesh current, this current flowing, that is the mesh current, that this I1 is current flowing through the mesh 1, so I1 is called mesh current. Similarly, the current flowing through this mesh 2 is I2, that is why it is called mesh current I2, and similarly the current flowing through this mesh 3 is I3, that is why I3 are called mesh current. So I1, I2 and I3, they are all called mesh currents. They are all called mesh currents. Now from the figure 9, if you see that again we have a dependent source connected in between mesh 1 and mesh 2, which is 3i, which is dependent on 3i, and that current I is flowing through this 1 ohm resistor, flowing through this 1 ohm resistor, right? So now if you closely look that through the 1 ohm resistor, I3 is flowing in this direction, I3 is flowing in this direction from right to left, and I2 is flowing in this direction. So naturally we can write that current I that is flowing through the 1 ohm resistance is nothing but I2 minus I3. That is our first equation. I is equal to I2 minus I3, because 1 ohm resistance, the mesh 3 current is flowing from right to left through 1 ohm resistance. Mesh 2 current I2 is flowing from left to right. Now as indicated in the problem, the current flowing through the 1 ohm resistance is I, which is flowing from left to right. So that is the reason we must write I is equal to I2 minus I3. That is equation number 14 for us. Next we proceed to write KVL for mesh 1. KVL for mesh 1. So we have three requirement, or rather we have three components. Number 1 component is 12 volt source. Second component is the potential drop across 4 ohm resistance, which is nothing but is equal to 4 into I1 minus I3. That is the potential drop across 4 ohm resistor. Now what is the reason I have written? Let us consider the polarity is this, left side is plus, right side is minus. So the mesh current I1 should be flowing from plus to minus. The mesh current I3 should be flowing from right to left, that is from minus to plus. So the net current should be flowing from I1 minus I3. So due to this fact, we have written 4 into I1 minus I3, and that is subtractive polarity with respect to 12 volt source. Okay. Next we have this 3i. Next we have this 3i, right? This is again a voltage source, 3i. So 3i is written here. So with respect to this voltage drop across 4 ohm, it is additive. So it is added with this term. So 4 into I1 minus I3 it is written. Now what is I? Using equation 14. So I is written as 3 into I2 minus I3. So if you solve this equation, you will get a equation 4I1 plus 3I2 minus 7I3 equal to 12, which is our equation 15. Now let us proceed towards, mesh number 2. So mesh number 2, let us first investigate how many components are there. We have first 6 volt source, that is number 1. Number 2 is the potential drop across 1 ohm resistor. Potential drop across 1 ohm resistor. As indicated in the problem, the current is flowing from left to right. So this must be left side of the 1 ohm resistor must be plus, right side must be minus. So now with respect to the 6 volt source, minus plus, though these voltages are additive, and 3I, this voltage is subtractive. So we write P into I, which is the dependent source, which is I2 minus I3, and that is equal to 1 into, again 1 into I is what? I2 minus I3 plus 6, as it is mentioned, or as it is just pointed out, these two voltages are additive. So if you solve this, then we get I2 minus I3 is equal to 3, which is our equation 16. Now from mesh 3, it is very important. Now luckily we are fortunate enough to have this problem. Now mesh 3 current is I3. Now from itself, it is very clear that I3 is equal to 5 ohm, because the mesh current I3 is flowing through the entire mesh. So because it is mesh current, so it is flowing through the 2 ohm resistor, and it is also this current. So I3 we can directly write it is equal to 5 ampere. So this will make our work easier. So I3 is equal to 5 ampere due to this reason. So now you can solve from equation 16 that I2 is equal to 8 ampere. Is quite straightforward. If I2 minus I3 is equal to 3 and I3 is equal to 5 ampere, then I2 must be equal to 8 ampere. And from equation 15, it is straightforward. If you solve, then we will solve I1 is equal to 23 by 4 ampere. So with this, by mesh analysis, we solve I1 is equal to 23 by 4 ampere. I2 is equal to 8 ampere and I3 is equal to 5 ampere. Luckily, to solve this problem, we need not encounter to solve Cramer's rule that we have already discussed in the previous module. So luckily, due to this fact or this data, I3 is equal to 5 ampere, the problem is solved quite easily. Okay, this is mesh analysis. By mesh analysis, we write down 2 or 3 equations, then we solve one by one, and we conclude, and we reached at our solution. Let us proceed our next problem. Now this problem is about nodal analysis, right? This problem is about nodal analysis with dependent source. So dependent source is 2I. What is I? The current flowing through 1 ohm resistor. The current flowing through 1 ohm resistor, right? This is I. Now in the circuit shown in figure 10, find the current I. So itself, so it is asked what is the current flowing through. That is, it is that this I should be evaluated. This is the circuit. Okay, this is the network. So we have 1 ohm connected across the terminal X and Y. So we need to consider. So now Must understand the network. Let us consider the KCL at node Y. Okay, so let us point out one by one how many currents are associated to node Y. Now it is clearly seen at first glance we have connected, or we have 1 ohm resistance. So one current I is flowing into the node. That means the current I is entering. Okay. Again we have 1 ampere current source that is also flowing into the network. That means it is also entering. Now with this we have this 3 ohm resistance. With this 3 ohm resistance connected, and this current must be leaving. This current must be leading because of very obvious reason. This node should be at higher potential with respect to this node. This node must be in ground potential, right? So node Y should be placed at higher potential with respect to ground. So one current should be flowing through the resistance 3 ohm, and this flowing from the node Y. That means this current should be leaving. And additionally another current which is 2I, it is also leaving from node Y. This is 2I. Right? This is also 2I, and this current should be flowing through this 2 ohm resistance. So let me complete the figure first. So we have indicated all the entering current by red and all the leaving current by black, right? So this is 10 volt source. So entering current, the first current is I, second current is 1 ampere. So these two currents are entering. And how many are leaving? So one current is leaving, that is 2I, and another current is leaving through this 3 ohm resistor. That is the leaving current, right? So this leaving current is nothing but Vy by 3. Leaving current is nothing but Vy by 3, because you see the potential drop across this 3 ohm resistance is Vy, because it is ground node. So this current must be Vy by 3. So that is exactly written in this equation. I plus 1 is equal to Vy by 3 plus 2I. And if you solve this, or if you simplify this, you will have Vy by 3 plus I is equal to 1. Right? Which is equation 17 for us. Which is equation 17 for us. Now applying KVL, where we apply KVL at this loop. This loop we are applying the KVL, right? So let me point out the polarities. Okay, so the current I is flowing through the 1 ohm resistance, so this must be polar in this fashion. And 3 ohm resistance, current flowing from Y to G, so this must be, this potential drop across 3 ohm resistance, this must be this. So the potential drop across 1 ohm and potential drop across 3 ohm, they are additive polarity. So we can write 1 into I1 or 1 into I plus Vy. Plus Vy, simple. Okay. Because this potential is Vy. And that must be is equal to 10. Because equal to 10, subtractive 1 with respect to remaining 2. So that is why it is straight away right, 10 is equal to 1 plus Vy. N is equal to 1 plus Vy. That is equation 18 for us. Now if you solve this equation 17 and 18, you will get answer I is equal to minus 7 by 2. I is equal to minus 7 by 2. This current actually we have assumed it is flowing from left to right, but actually it is flowing from Y to X. So you must mention that the direction of the current I is from Y to X. This is the direction. It is magnitude is 7 by 2. Magnitude is 7 by 2 ampere. However, the direction, actual direction is from Y to X. So we both apply the principle of nodal analysis and mesh analysis in this problem to solve the current I, which is found to be 7 by 2 ampere. So if you encounter, with these 10 problems that we have discussed in this module, one thing we can understand that if you encounter a dependent source, that problem is not so much difficult. It will take some more time to solve. Okay, and you need to analyze the circuit very well. To understand the circuit, to analyze the circuit rightly, appropriately, you need more practice. More you practice the various kinds of problem, the better your confidence, better your grip on the problem, better your ability to solve the different problems from the network. So with this, we are done on this module. So this network solving technique purposely has been split into two parts. In the first phase, which was covered in module 4, that is plain simply DC network, which is the initial, that is the introduction part, that is the familiarization part. And in the module 5, we have incorporated the dependent source, AC source, all of these things, some advanced type of problem, and we have we have solved all of those problems, various types of problems on them. So as a student, you need to solve them effectively. To do that, you need practice. No alternative to that, no shortcuts on that. You need to practice more and more. The more we'll practice, better will be the grip of the problem, better will be the ability of you to solve the problem. Okay, with this we are concluding the module 5 here. So from the next session we shall start module 6, which is two-port network. So with this, thank you.